Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA June 2023, Paper 2, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a, here is a number line. What number is at x? Okay, so we've got several numbers marked on this scale. We've got 0 marked, and then we've got 20 marked. And then between those we've got 1, 2, 3, 4 jumps, haven't we, to go from there to there. So that means each one of those jumps is 20 divided by 4, isn't it? So 20 divided by 4, that means each jump is worth 5. In other words, it's going 5, 10, 15, and then 20. So keep going, 20, 25, 30, 35 then is x, isn't it? So x is the number 35. Okay. Part B says here is a different number line. Now again, if you have a look at the two numbers we've been given, so we've been given, well, let's use 0 and 6 here. So then from 0 to 6 is 1, 2, 3 jumps, isn't it? So if we take the span, which is 6, and we divide it by the number of steps, which is 3, it should tell us the value of each step. It's going to be going up in 2s, isn't it? So if I'm going from -6 and I add 2, it's going to be -4. Then add another 2, it's going to be -2. Then 0, 2, 4, 6. Okay, so then y is going to be at -2. Question 2, match each expression on the left with a simplified expression on the right. Okay, so first one's been done for us, 14a minus 2a, that is indeed 12a. So what's 3a plus 4a? I've got two numbers with the same letter, like that, like terms, so we're just going to add those numbers in the front. The 3 plus 4 is going to give me 7. So that's 7a, isn't it? So 3a plus 4a is the same as 7a. That's that one there. 3a times 3a, well, 3 times 3 is 9, and a times a is a squared, isn't it? So this is going to give me 9a squared. So where's that then? That's down there. 6 times 3a, I've got 6 times 3, that's 18, and then an a on the end. So that's going to be 18a. So where's 18a? That's that one. And then finally 12a divided by 4. So 12 divided by 4 is 3, and then I've got an extra a, haven't I? So it's going to be 3a. So where's 3a? Oh, it's up there. Okay, job done. Question 3, here are some shapes. Each shape has the area of 6 square centimeters. Which has the biggest perimeter, shape A or shape B? You must show the lengths of both perimeters. Okay, so the perimeter is the distance around the edge of the shape. So if you imagine I start from A in that top left corner, then walking around the shape, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 around the shape. So the perimeter of A is 14, and then the perimeter of B, again, I'm going to start in the top left corner, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 jumps all the way around. So the perimeter of B is equal to 12. So which has the biggest perimeter? Shape A. Okay. Which shape is congruent to shape A? So congruent means exactly the same shape and size. It could be a reflection though, so it could be flipped over, it could spun round. So looking at those shapes, well, it's going to be D, isn't it? These two are the ones that are like. So D is A rotated and flipped over, isn't it? So it's going to be shape D. Question 3 says, which two shapes fit together to make a rectangle? Well, if you took shape E and you fit it up against shape C, you see that would give you the rectangle there. So I think C and E would work. So shape C and shape E. And then part D says, on the grid, draw a reflection of shape C. Show your mirror line. So let's just draw the mirror line in first. I think I'm going to draw it, I could reflect it downwards. Got plenty of space and go in any direction I want. I think I'm going to go this way though. Okay, so then take it each corner of my shape. There's a corner here. Its image is 1 unit away from the mirror line, so its image is going to be 1 on the other side. It's going to go here. Okay, then this point over here, look, that lies 1, 2, 3 units away from the mirror line. So 1, 2, 3 units away on the other side is going to be its image point. And if we do that for each of the corners of this shape, you will trace out like that F shape then, aren't you? Okay, just joining that together with straight lines. Getting rid of our little jump lines there. So there's my F reflected. Question 4. Points P and Q are shown on the grid. Write down the coordinates of P. Okay, so P, we measure coordinates along the corridor and up the stairs, don't we? So we're going 1, 2, 3, 4 along and 1, 2, 3 up. So that's going to be the coordinates 4, 3 then, isn't it? Okay. And then angle PQR is a right angle. Work out a possible coordinate for R. So PQR is a right angle. So if I just join those two lines up, P and Q to start with, then right angle or perpendicular to that line is this line here, isn't it? So R is going to have to lie somewhere along this line where I've got the ruler, anywhere along this line here. Okay, so I'm just going to pick a point along here, doesn't really matter. Okay, anywhere along that line, y is equal to -3 would be fine. So I'm just going to have to pick that one there. So there's my R there. Okay, so yeah, and that's a right angle, but I could have had any number as long as the y coordinate is -3, then the x coordinate can be whatever you like. So it's a number, comma, -3 would be a right angle. Question 5a, a shop sells bottles of orange juice. Each bottle costs 75p. Work out the greatest number of bottles that can be bought with £5. Okay, so we're going to have to do some division here, but we have to think about how we're going to round this number off. So the number of bottles is going to be equal to £5 divided by the cost of one bottle, then, isn't it? 75p. Now, try to get into the habit of writing down things before you type it into the calculator, because there are marks. This is a 2-mark question, and knowing you have to divide by 75 is probably going to be one of the marks, isn't it? So at least doing that, you're going to get some of the marks even if you don't get all of them. So that's going to give me 6 2/3 or 6.6 recurring, or I'm just going to round it off though to 6.67 when I write it down. Now obviously that would normally round up, isn't it? If you wanted that to the nearest whole number, 6.67 would normally round up to 7, but we can't afford that 7th bottle. We can afford 6 and a bit bottles of juice, so we can't afford the 7th one. So in this one we're going to have to round down to 6 bottles. Okay, so sometimes questions you have to round the wrong way, don't you, because of the constraints of the question itself. Part B says 2 shops sell bottles of apple juice. Shop X sells packs of 4 bottles. They were £2.50, now they're 10% off. And Shop Z sells packs of 12 bottles at £7. Which shop is it cheaper to buy 24 bottles? Show your working to support your answer. Okay. Well, if I've got 10% off, 10% of £2.50 is 25p, isn't it? It's quite an easy thing to do. I can just divide it by 10. So if I subtract £2.50, subtract 25 pence, that's £2.25, isn't it, for 4 bottles? So from Shop X, if I want to buy 24 bottles, I'm going to have to divide 24 by 4. 24 divided by 4 is 6, isn't it? I'm going to have to get 6 4-packs to get 24 bottles. So I'm going to get 6 lots of £2.25 then, and that's going to cost me 6 times 2.25. That comes to £13.50, or 13.5, £13.50. And then Shop Y, they come in packs of 12, so I'm going to need 2 of those, aren't I? So 24 divided by 12 is 2, so I need 2 packs of 12 bottles. So 2 lots of £7, that's giving me £14. So that means Shop X is slightly cheaper, so Shop X is cheapest. Okay, question 6. The game has 4 cards labelled A, B, C and D. Ellie picks 2 of the cards at random. Complete the list of the 6 possible pairs of cards that she could pick. Now, presumably order is not important here. A, B in the context of this question is the same as B, A. Otherwise, we'll have more than 6 outcomes. So, yeah, order can't be important. So, A, B is one possibility. So, keeping A the same and switching B out for C gives me A, C. And then switching A for the next one is A, D. Okay, so I've done all the ones with A in it, so I'm going to pick B now. So I'm going to have B, C and B, D, and then I've done all the ones with B in, so I'm going to switch to C, and I've only got one left. I've got C, D. Okay. Question 7a. Complete the boxes using 2 different even numbers and 2 different odd numbers. So I need to get 2 odd numbers and 2 even numbers that add up to 46. Okay, so I'm just going to work out what 46 divided by 4 is to start with, so I can get an idea about what size of numbers these need to be. So 46 divided by 4 comes to 11.5. Okay, so I could, so if I picked 11 and 12, what's that? That's 23. That's half of it already. So I guess if I then pick 10 and 13, that's another 23, isn't it? So I've got 2 different even numbers, 10 and 12, and I've got 2 different odd numbers, 11 and 13. So like I said, I just divided it first to get a kind of an idea where a quarter would be, and then I picked 4 numbers around that to come up to my answer of 46. So 10, 11, 12 and 13. Now there are other choices, but yeah, that was the kind of easiest way for me to work it out. B says complete the boxes using a factor of 12 and a factor of 40. So what are the factors of 12? The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of 40, I've got 1 and 40, 2 and 20, 3, nope, 4, yep, 4 and 10, 5, yes, 5 and 8, 6, no, 7, no. Okay, so they're all my factors of 40. I guess what I want, though, is I want a factor pair that I can pick one of each. So if I can just list out the factor pairs of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now, can I pick those combinations from here? Well, I suppose I could take 5 and 6, couldn't I? So 5 and 6, I've got a 6 there and a 5 there. So 6 is a factor of 12, 5 is a factor of 40, multiply them together, I get 30. So I'm going to go for 5 and 6. Notice we could have also had 3 and 10, that would also work. Look, 3 there and 10 there. Any other possibilities? No, they're the only ones, aren't they? Okay, so I could have had 3 and 10 as well. Part C says complete the boxes using a square number and a prime number. So something divided by something is 18. Now, the number here has to be a multiple of 18, then, isn't it? So if you're going to divide it by something and get 18, then that number there is a multiple of 18. So that number there can't be the prime number, it has to be the square number. So we're looking for a square number that is bigger than 18, and then I can divide it and I can get 18 by a prime number. So what are the prime numbers? Prime numbers are 2, 3, 5, 7, 11. So I guess if I try some of these out and think, well, what would I have to divide by each of these numbers, and then see if it is a square number. So if I pick the 2 here and put it here, look, something divided by 2 is 18. What divided by 2 is 18? It's 36. Yeah, so that actually works, isn't it? So I'm just going to use those two. So 36 is a square number, it's 6 squared. 2 is a prime number. Okay, now there might be other ones that work as well, but I found a pair and I don't feel the need to go and keep on looking. But if you've got another pair that works, good on you. But they're the ones that I found. Question 8. 93 people were asked if they played online games one day. The frequency table shows some information about their answers. So 93 people were asked. People who said yes was 48. So presumably the other half, or the rest of them, said no, not the other half. So 93 divided by 48. What's that? 93 minus 48. What's that? 93 minus 48, that comes out to be 45, so 45 in there. And then played more than one game played. 75 of the people who answered yes played one game. So what is 75% of 48? Well, that's going to be 48 times by 0.75 then, isn't it? So 48 times by 0.75, or 3/4 of 48. That's 36. And then I suppose 1/4, or the rest of it, which is 12, must have played more than one game. Okay, so we've completed our frequency tree. Good job. Part B says one of the 93 people is chosen at random. Probability of used social media is more than 0.68. What is the smallest possible number of people who use social media? Okay, so what we're saying is, let's say n is the number of people who use social media. So then n divided by 93, the probability of using social media, is going to be the n people who use social media divided by 93 people who were the sample we were picking from. And we know that's has to be more than 0.68. So we formed an inequality in n here. Now multiplying both sides through by 93 times 93 times 93, I'm going to get n is greater than 0.68 times by 93, and that comes to 63.24. Okay, now obviously n needs to be a whole number, isn't it? It's the number of people who use social media, so it can't be a fraction, and n has to be bigger than 63.24. So what is the smallest possible number it can be? Well, it's going to be the smallest number that is bigger than 63.24, and that is 64, isn't it? So 64 is the answer. Question 9a. The cost of a TV streaming service is £6 per month for the first 4 months, then £11 per month for the rest of the year. Work out the total cost of the year. Yes, like all these companies want to sign you up with a cheap rate and then they hike up the price, don't they? It's fairly typical business practice, unfortunately. So yeah, £6 for the first 4 months. So first 4 months, that's going to cost us 6 times 4 then, that's £24. And then the rest of the year is going to be 12 minus 4. It's going to be 8 more months, isn't it? So the next 8 months after that, we're going to be paying 8 lots of £11. So 8's 11, so it's 88. So then the total we're going to be paying is those two amounts added together then, isn't it? So 88 plus 24, 4 and 8 is 12. That's going to be £112 altogether, isn't it? Okay, £112. 9b, a TV series has 10 episodes. 9 episodes are each 50 minutes long. 1 episode is 1 hour 42 minutes long. Work out the total length of the series. Give your answer in hours and minutes. So I've got 9 episodes at 50 minutes. And that's, so the total amount of those times is going to be 9 times those 50 minutes, isn't it? Okay, now I'm going to use the time key on the calculator to do this. So I'm going to do 9 times and then 0, press the time key, and then the 50, and then press the time key. So that's 9 lots of 50 minutes. And you can see that comes to an answer of 7 hours and 30 minutes. So I'm just going to write that down as 7 hours and 30 mins. Okay, and then I've got one episode at 1 hour 42. So I'm going to add that on then. So adding on 1 hour 42 onto this. So again, I'm just going to use the time key. I'm not going to bother working out myself. So I'm just going to press plus, and then I'm going to say 1, and then the time key, and then 42, and then the time key. So that's our previous answer of 7 hours 30 minutes plus 1 hour 42, and that comes out to 9 hours and 12 minutes. 9 hours and 12 mins. Okay, so that time key is super handy. You could do all sorts of arithmetic with it quite easily once you've kind of built your confidence in using it. So 9 hours and 12 minutes. Question 10a. There are 1,020 books in a box. That's a big old box of books. 2/5 of the books are blue. How many are blue? Okay, so 2/5 of 1,020 then, isn't it? That's what we want to work out. What is 2/5 of 1,020? Now, if this was the non-calc, I'd be dividing through by 5 and timesing by 2, but I've got a calculator in front of me, so I'm just going to use the fraction key. So 2 over 5 times 1020. Calculate, what's that? It's 408. 408. 408. Okay, there are green pens and red pens in a box. The ratio of green to red is 4:3. What fraction of the pens are green? Okay, well, there are 4 shares and 3 shares. 4 shares of green pens, 3 shares of red pens. So altogether is 4 plus 3 equals 7 shares altogether. So then the fraction that are green is the 4 green shares divided by the 7 shares. So that's 4/7. Question 11. Here is a Venn diagram. The universal set consists of 60 people. H is the people who own a gaming headset, and W is the people who own a smartwatch. So I've got 24 people that own a headset but not a smartwatch. 7 own both. We don't know who owns just a watch by itself or neither yet, but we've got some more information down here. It says 15 of the people own a smartwatch. Okay, so 15 of the people own a smartwatch. So 15 is the number of people inside this circle. Okay. However, we've already accounted for some of those, haven't we? We've accounted for 7 of them. So what's left then in the other side is 15 minus 7. 15 minus 7, that's 8. So there are going to be 8 people who own a smartwatch only. So adding the 7, that's going to give me the 15 who own a watch overall. Okay. So can I complete it now? Well, yeah, I can, because I also know that there are 60 altogether, and I've got 3 of the values so far. So I know that this number here outside the set is going to be 60 minus the other 3 then, isn't it? So 24 plus 7 plus 8. What's that then? So 60 minus 24 plus 7 plus 8. 24 plus 7 plus 8. That's 39. Take that away from 60. Was 21. Okay, so there are 21 people who own neither. Part B says one of the 60 people is chosen at random. What is the probability that they own both a headset and a smartwatch? So what's the probability that they own both a headset and a smartwatch? That's just the notation for the bit in the middle, the intersection of the two. That's the bit we're interested in here, isn't it? That both is that bit in there. So there are 7 people in that range, and then out of a total of 60. So the answer is 7 over 60. Part C says Marek is going to buy a gaming headset that costs £35. He already has £19. He plans to save the rest in 2 equal amounts over the next 2 weeks. He uses this method to work out in pounds how much he needs to save. each week. So he's got 35 pounds, he's going to deduct the 19 and then he's going to divide that by 2. What is wrong with his method? Well, Merrick, you've made a mess of your order of operations. You should know about BIDMAS, brackets, indices, division and multiplication, addition and subtraction. Okay, so the way he's written it down reads 19 divided by 2, which would be 9.5, taken away from 35. That's not what he wants to do. He actually wants to do the subtraction before the division, doesn't he? So he needs to do the subtraction first. So what did he do wrong with his method? He forgot to use brackets around the subtraction. Should be 35 minus 19 divided by 2. Okay, so 35 minus 19, that would be 16 when it divided by 2 is 8. So you'd have to save 8 and 8, and that together would give him 35 pounds. Question 12. Kai says that 3 to 2 is an equivalent ratio to 9 to 6. Joe says that 1.5 to 1 is an equivalent ratio to 9 to 6. Who is correct? Tick one box, give reasons for your answer. Okay, well, for Kai, we've got the starting ratio of 3 to 2. Now, if I take that and I times it by 3, then I'm going to get 9 to 6, then, aren't I? So these are two equivalent ratios. And if I take Joe's ratio of 1.5 to 1, I can also times it up. I can times it up by a factor of 6. So if I times 1.5 times 6, 6 and half of 6, that's equal to 9. And 6 times 1 is also 6. So actually they're both right, aren't they? So they're both right. Okay? Now you don't have to give a wordy reason as your answer. That maths over there is plenty good enough. Question 13. 28 is increased by 25%. 40 is decreased by 15%. Which answer is bigger? Show how you decide. Okay. So I'm going to do some more percentages here. So I'm going to use my triangle FOM again. Final, original, multiply. Stick your thumb on it. What's F? What's O? What's M for the first part? 28 is increased by 25%. Okay, so 28 is my original value. So 28 is the original value. Okay, so that's going to go here. Original is 28. It's increased by 25%. So when you've got a percentage increase, you start with 100% and then you're adding on your percentage increase, which is 25%. So altogether, that's 125%. And as a multiplier, that's 1.25 because it's a decimalized version of the percentage. Now the final is the thing we're trying to find, isn't it? So covering that up in the triangle, it tells me that the final is original times multiplier. Okay, so this, in this case, is going to be 28 times 1.25. And 28 times 1.25, that comes to 35. Okay, so that one is 35. Now, on the other side, I've got final, original, multiplier again. Now, I've got 40 this time, so that's going to be my original value. And then this time I've got a decrease of 15%. So again, we're going to be starting with 100% and we're going to be subtracting 15% this time. So 100 take away 15, that's 85%. And 85% as a multiplier is 0.85. Okay? So multiplier, multiplier. Okay, so then I need to work out final again. So again, final equals original times multiplier. Okay, so it's going to be 40 times by 0.85 then, isn't it? So what's 40 times 0.85? That comes to 34. So which is bigger? Then it's going to be 28% increased by 25%, isn't it? So 125% of 28 is bigger. Question 14, factorize 12a plus 15b. And now you can see a and b are different, so they're not going to be able to factorize, are they? But 12 and 15, they share a common factor. They're both in the 3 times table. So I can take 3 out because 3 goes into 12 and 3 goes into 15. And then I need to think, well, what times 3 is going to give me 12a? Well, it's going to be 4a, isn't it? 4a times 3 is 12a. And what times 3 is 15b? It's going to be 5b, because 5b times 3 is 15b. So factorising 12a plus 15b gives me 3 lots of 4a plus 5b. Question 15, write down all the integers that satisfy the inequality. Okay, so I've got minus 3 is less than or equal to x, which is less than 2. Okay, now I think it's sometimes easier to visualize this on a number line. If you've got the latest Casio calculator, you can get it to draw you a number line for you. So if you go to hit the home key and you go down to math box down here, you see you've got one called number line. So if you go on number line, and then you've got A, B and C. Now, so if I press execute on there, can you see that I've got x is less than a, x is less than or equal to a, x is equal to a, x is greater than a. And if I scroll down, we should find a format that matches the question that we've got. Okay, not that one, it's that one, isn't it? So x lies between a and b, where it's the one on the left is greater than or equal to, and the one on the right is strictly less than. So that's the one I want. So I'm going to select that one. So the value of a, the left limit, is going to be minus 3. And the value of b is going to be the right limit, it's going to be 2. And if I press confirm, I'm just going to go down and execute that, because I've just got the one condition here. It can do more than one. But you can see then it's drawn it for me. Okay, so that's what it looks like. I've got a closed dot on the left hand side because minus 3 is included, and an open dot on the right. So all the numbers in between are going to be the numbers I want. Now unfortunately it's not drawn such a nice scale for me, but if I press the right key, that's a little bit nicer. Yes, I just shuffled along a little bit until I got a scale that looked a little bit nicer to use. So I've got minus 3 on the left. Now that is part of the number line. So I'm going to put minus 3 as one of my numbers. Then I can have minus 2, minus 1, or 0, or 1. Now all those numbers lie between minus 3 and 2. Now 2 is the other limit, but 2, x needs to be strictly less than 2, so it's not that one. Okay? Okay, so it's probably a bit overkill using the number line thing there on that one. You could probably just work it out without, but it's a useful tool, so I thought I'd start bringing it up in my walkthroughs to show it off. Question 16, a linear sequence starts 7, 10, 13, 16. Work out an expression for the nth term of the sequence. Okay, so when we're looking for an nth term, the first thing we need to know is the common difference between your terms. This one, can you see what's going up in? This is plus 3, isn't it? Plus 3, plus 3, plus 3. So whatever the common difference is, I know I'm going to get 3n as part of my term. Whatever that common difference is the thing that I write in front of the n for the nth term. But 3n, when n is 1, remember the first term n is 1, so 3 lots of 1 would be 3. 3 lots of 2 would be 6. 3 lots of 3 would be 9 and 12. So subtracting that, can you see I've got a difference here of 4. So 7 is 4 more than 3, 10 is 4 more than 6, 13 is 4 more than 9, 16 is 4 more than 12. So each one of these is add 4, aren't they? So add 4, add 4, add 4. Okay, so my final expression is going to be 3n because it's going up in 3s, plus 4 because I need to add 4 onto 3, 6, 9, 12 to get 7, 10, 13, 16. Jess saves 2p, 5p and 10p coins. She has 45 10p coins. She has 8 times as many 2p coins as she has 10p coins. And she has £17.70 in total. Find out the total value of the 2p coins to the total value of the 5p coins written as a ratio and given it in its simplest form. Okay. Right, so let's just work this through then. So she's got 45 10p coins. So 45 times 10p coins, and we have 8 times as many 2p coins as 10p coins. So in other words, she's got 45 times 8 2p coins, and isn't she? What's 45 times 8? Well, that's double, double, and doubling again. So 45 double is 90, double it is 180, double it is 360. So 45 times 8 is 360. She's got 360 2p coins. So what she's got, 45 10p coins, and she's got 360 2p coins. How much is that altogether then? So that is equal to 450 plus 720, which comes to 770, 1,170, or £11.70 worth of change so far. Okay, so that's the amount of 2p's and 10p's she's got. So that's the value of 2 and 10p's is this. So the value of the 5p coins is going to be the total cost less what the other 2 coins were worth, isn't it? So if I take, I think I'm just going to stick with pence for now, 1770 minus 1170. So that leaves me with 600 then, doesn't it? Or £6 worth of 5p's. Okay, so then what I want to know then is the number of 5p coins. Oh, do I need to know the number? No, I need the values. So I've got, so that's the value then of my 5p coins, and the value of the 2p coins we said was 360 times 2, that's 720. So then the ratio of the value of the 2p coins to the value of the 5p coins is going to be 720 to 600. Now to cancel that down, I'm just going to use the fraction key on the calculator because ratios cancel down pretty much the same way. So if instead I write 720 over 600 using the fraction key and press equals, it's going to cancel down that fraction for me. That's given me 6 over 5. And so they're the same values I can use in my ratio then, can't I? So this isn't a fraction, but it cancels down the same way, so that's going to cancel down to 6 to 5 as well. Okay, so that's my answer, 6/5. Question 7. In a game, an ordinary fair 6-sided dice is rolled. The fair spinner is shown is spun. The score is the dice number substituted into the spinner expression. What a fun game. Complete the table to show all of the possible scores. Okay. So, if it lands on 1 and 2x, then 2 lots of 1 is going to be 2. If it lands on 2x and 2, then 2 lots of 2 is 4. 2 lots of 3 is 6, 8, 10, and 12. If it lands on 3x and 1, so 3 lots of 1 is 3, 6, 3 lots of 3 is 9, 3 lots of 4 is 12, 3 lots of 5 is 15, 3 lots of 6 is 18. And then if it lands on x squared and 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25, 6 squared is 36. Part B says the player wins the game if their score is 10 or more. Work out the probability that they win the game. Okay, so probability of win is successful outcomes, scores more than 10, divided by total outcomes. How many outcomes there are altogether? Well, in this grid, it's a 3 times 6 grid, and 3 times 6 is 18. So there are 18 outcomes altogether. Now, how many of those outcomes are 10 or more? Well, that's 10, and that's more than 10. That's more than 10, that's more than 10, that's more than 10. That's more than 10, that's more than 10, that's more than 10. So I make that 2, 4, 6, 8 outcomes that are more than 10. So the probability then is going to be 8 out of 18. Part C says the game is played 711 times. Estimate the number of games that are won. Right, so expected number of successes is going to be the probability times the number of trials. Okay, so in this case, it's going to be 8 over 18 times 711, whatever that is. So 8 over 18 times by 711, it comes out to 316. So I would expect there to be 316 wins. I'd like to get exactly that, but it's going to be there or thereabouts. Question 6a. Part of the regular polygon is shown. Assume that the polygon is an octagon. Work out the size of the exterior angle. Okay. So if it's an octagon, then it has 8 sides, and as it has 8 exterior angles, and the exterior angles all add up to 360 degrees, then we can say that one exterior angle is equal to 360 divided by the number of sides, 8. And 8 goes into 360, 45. So that's 45 degrees. Part B says, in fact, the polygon has more sides than an octagon. What does this mean about the size of the exterior angle? Okay, so we did have the size of the angle was equal to 360 divided by 8. But if it isn't 8, if it's bigger, then the denominator of my fraction is getting bigger. What does that mean in terms of the overall size of the number? If you get a bigger denominator, then overall your fraction is smaller, isn't it? Because a quarter is smaller than a half. Okay, so the bigger the number part of the denominator is, the smaller the fraction is. So that means the overall size is going to go down. Okay, so tick one box. What do we know about the size of the exterior angle? It is more than the answer to part A. No, it's the same as answer to part A. No, it's less than the answer to part A, isn't it? So it's that one. Okay, it's definitely less. Write down the translation vector that maps shape A onto shape B. Now, when you're drawing translation vectors, make sure you are joining like points with like points. I often see students, drawing a line between the two closest points on the shape, like that one there. But you'll notice I'm joining, if I do that, I'm joining the top right corner of A to the top left corner of B, so that's not correct. Okay, so it has to be like corners with like corners. So pick a shape on one object, pick the matching point on the other, and then look at your vector that lies between those 2 points. We're going from A to B, so my line is going this way. Okay, so what is that vector there then? Well, it is so many units to the right and so many units up. So that's going to be what, 1, 2, 3, 4 units to the right and 1, 2, minus 3 units up. So that's going to give me the vector 4, minus 3 there. 4, minus 3. Now vectors are not fractions, so don't put a line in between them like that. And they're not coordinates. They've got one number on the top and another number underneath. Okay, do it like that, you'll get the marks. And you're given the formula for the volume of a sphere. It's 4/3 pi r cubed. A bowl is a hemisphere with radius 12 centimeters. Water is poured into the bowl at a rate of 325 cubic centimeters per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show your working. Okay. So, note first of all, we've got the volume of a sphere equation and we want a hemisphere. So we're going to have to adapt this, aren't we, to make it into the volume of a hemisphere. So the volume of a hemisphere is going to be half of the volume of a sphere, isn't it? So it's half of 4/3 pi r cubed. Okay, so probably you can just divide that 2 into the 4 and make it 2/3 of pi r cubed then, isn't it? Okay, that's what you want. And then what is r? R we're given as 12, so that's 2/3 of pi times 12 cubed. Okay. Now I'm going to type this into the calculator, but I'm just going to leave it in terms of pi now, just to make it easier to write down. So I'm going to do 12 to the power of 3, and then times 2 divided by 3, and that comes to 1,152. So that is 1,152 lots of pi. Okay, I'll evaluate it at the end. I don't really need it now. So water is poured into the bowl at a rate of 325 cubic centimeters per second for 8 seconds. So how much water goes in then? So volume of water that goes in, that is just going to be the number of seconds that water was going in multiplied by the amount that's going in every second, isn't it? So that's 325 times 8. So 325 times 8, that gives me 2,600. Okay, cubic centimeters. So does the water fill more than 70% of the bowl? is 2,600 70% of 1,152 lots of pi? Okay, well, let's find out. So percentage would be, so percentage filled would be the amount of water going in divided by the amount of water that it could hold times by 100 to make it into a percentage then, isn't it? Okay, so what's that then? So 2,600 divided by 1,152 lots of pi times 100. I make that 71.8 and change. So just rounding that off, I'm going to make that 71.8%. So does the water fill more than 70% of the bowl? Yes, it does. Yes. More than 70% is filled. Okay. Show that these two rectangles are similar. Now, if two rectangles are similar, then all their sides are going to be in the same ratio. So what is that ratio then? So if I take these two and form a ratio, I'm going to get 5 over 12. Okay. And then if I take the other one, I'm going to get 8 over 19.2. Is that the same thing as 5 over 12? I don't know. Well, let's just type it into the calculator. 8 divided by 19.2. Oh, yeah, look, it's 5 over 12. So that is equal to 5 over 12. So we can say the sides are in the same ratio. When that was 5 over 12. And so the rectangles are similar. Okay, so the sides are in the same ratio, and so the rectangles are similar. Okay, so often with these questions we're finding like you know, like the scale factor here, but this time we're doing something different. We're just showing that the sides, when you divide one by the other, you get the same number, and therefore they must be in the same ratio, and therefore they are similar. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x over 3 tea bags per minute. Okay, so if a factory packs X boxes of tea bags per hour and each box contains 80 tea bags, then tea bags per hour is going to be the number of tea bags in each box times by the number of boxes, which is 80x. Okay, so if I want to then do tea bags per minute, then I'm going to have to do 80x divided by 60 because there are 60 minutes in an hour. So 80 divided by 60, that comes to, well, it comes to 4/3. So that is the same thing as 4x over 3. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.